Okay, there are two ways you can solve this. The first way is to isolate the square and then use the square root property to solve for x. The first thing that I need to do is move this 1 to the other side. Make that a little bigger. There we go. Add 1 to the other side. So on the left side it cancels out, and I'm left with the 5x minus 4 squared. On the right side, 35 plus 1 is 36. And I have isolated the squared part. And here's where the square root method comes into play. To get rid of the, to get rid of this, sorry about that. I meant to use a highlighter. To get rid of this squared right here, you have to do the opposite of squaring, which is square rooting. And of course, you're dealing with an equation, so what you do to one side of your equation, you have to do to the other. And now the square root and the square cancel each other out, and that will also remove these parentheses. So I'll just be left with the 5x minus 4. Now, here's the part of the square root method you have to remember. When you take the square root of 36, you have to consider both possibilities of a positive and a negative 6. Because remember, whatever you have over here, you square it to get the 36. Well, all this stuff in the parentheses could have been a positive 6 squared to get 36, or it could have been a negative 6 squared to get a positive 36. So you have to remember that part. And this equation is a quadratic. If I took 5x minus 4 and squared it out, which is the other way you can do this, you'd end up with an x squared, which means there's two possible answers. Well, right here is where you get those two possible answers. It is going to be either a positive 6 or a negative 6. So you're going to have to split this equation of 5x minus 4. You're first going to take the 5x minus 4 and set it equal to the positive 6. And then the other one is the 5x minus 4, and you'll set that equal to the negative 6. So this one's the negative 6, and this one's the positive 6. And now I have two separate equations, and I can solve each one for x. So I'm going to add 4 here to both sides. That cancels that out. That leaves me with 5x is equal to 10. And then I'm going to divide off the 5, because 5 divided by 5 would leave me with just the x. But what you do to one side, you got to do to the other. So 10 divided by 5 gives me a 2. So there's one possible answer. And then the other equation, again, I'd start by adding 4 to both sides so that it cancels out on the left, leaving me with the 5x is equal to negative 6 plus 4 would be a negative 2. And then again, I would divide off the 5, because 5 over 5 leaves me with just an invisible 1x. But what you do to one side, you got to do the other. So you divide that side by 5, leaving you with negative 2/5. And there's the other possible answer. And then you'd go into Mobius and work it out. Now, the other way that you could work this is actually take the 5x minus 4 and square it, which could take a little while, but it can be done. Let's see, can I start a new whiteboard here? Nope, okay. Let me just close that out. The other way to do this is, I will just erase all this. Here, let me pause it while I do that. Okay. The other way is to take this 5x minus 4, which is raised to the second power, and actually take the 5x minus 4 times another 5x minus 4. You actually FOIL that. So first times first is 25x squared. Your outsides would be a minus 20x. Your insides would be a minus 20x. And last times last, a negative 4 times a negative 4, that's an x, would be a positive 16. But then you still have this minus 1 equals 35 here. Those have not gone anywhere, okay? And then over here, I still have the 25x squared. The minus 20x and the minus 20x would be a minus 40x. And the positive 16 and the minus 1 would be a positive 15. And at this point, I'd have to set this equal to 0. So let me get a different color here. I would subtract 35 from both sides. So it cancels out there. I'm running out of room, so follow me. So I'm going to have 25x squared minus 40x minus 20 equals 0. And then once you get it set equal to 0, you can either factor it or use the quadratic formula. I like to try to factor first, and I also look to see if I can divide out a common factor, which 25, 40, and 20 are all divisible by 5. And so is 0, because 0 divided by anything is still 0 over here. So this is going to be 5x squared minus 8x minus 4. And then I have to factor it, and you can try to do this in your head, or you can use the AC method, which I've explained in previous videos. Let's see, 5x squared has to be 5x times x. And then for the last term, this is a negative 4, so I know it has to be positive times a negative. If I put 4 and 1, that's not going to add up to negative 8. Remember, you're trying to add up to the middle term. 2 and 2 needs to be negative 8, so I need a positive 2 and a negative 2. That's going to give me positive 2x. That's going to give me negative 10x, which gives me negative 8x in the middle. So those are the factors. And now you take those two equations and you say, okay, either the 5x plus 2 is equal to 0, or the x minus 2 is equal to 0. All right, and then solve those. Here I would subtract 2 on both sides. That gives me 5x equals negative 2, and then divide by 5, and there it is. There's the negative 2/5. And here you would just add 2, and you get x is equal to 2. I get the same exact two answers. So either method works, or you could even, a third method, I guess, is once you get here or here, you could use a quadratic formula. You know, A is the 5, B is the negative 8, and C is the negative 4. So, and plug them into the quadratic formula. But once you do that, you're actually going to kind of get back to what I did before, where I had it set equal to positive or negative 6. So that's what's going to happen with the quadratic formula. Anyway, that's an overview of that type of a problem. I hope it helps.